Okay, this will be the last error review set of notes that we do. This is going to be over exponents, which we did earlier in the year, but we didn't do everything in its entirety. So just make sure we understand zero and negative exponents. So very first line of your notes, when you have a base raised to a negative exponent, you should flip it. So put in the blank, flip it. When you have a base raised to the 0 power, it is equal to 1, so anything to the 0 power is 1. When the same bases are multiplied together, you should add the exponents. I think that's the one that we did before here. When you have a base with an exponent that is raised to another power, so a power to another power, you multiply the exponents. And the last one, when you're dividing same bases, you subtract your exponents together. So if you're subtracting x's, if you're dividing x's, you subtract the exponents. So when we do these, those are the things that we have to keep in mind. So with this first problem that we have, and the middle of our notes, again, a to the 0 power gives us 1, so I can kind of ignore it. I know that my negative exponents are going to move, so I can move just the c and just the b. So the only thing left on the top will be c to the 3rd. On the bottom will be b squared d to the 6th. Nothing similar there, so I can't divide or add anything together after that. Here, again, the 0 only talks to the r, and so just the r is the thing that is going to be equal to 1. The m is the only thing with the negative exponent, which moves down. So the 2 stays on the top, and then the m to the 3rd goes to the bottom. Whenever I have something like this, so what I can do is I can go ahead and I can take my numbers and multiply them together, and then I can take the z's, and again, I can multiply them by adding the exponents together. So I get 36 as my number out in front of my coefficient, and then z to the 5th times z to the 12th gives me z to the negative 7th. Again, since it's a negative exponent, I want to move it to the bottom. Just the z moves, because that's the only thing that's immediately in front of the negative exponents. So the 36 stays on the top, the z to the 7th goes to the bottom. Here, same thing, multiply the numbers together, and then I can multiply my b's together. So I get 18, and then again I'm multiplying, so I add, so b to the 3rd. The next row down, whenever I have something like this, I can just multiply all my numbers together, and then all my a's, and then all my b's together. So my coefficients, I can multiply 2 times 3 times 5, which gives me 30. I can then multiply my a's together, which gives me a to the 6th power. Remember that there's an invisible 1 in front there. And then multiply my b's together. So b to the 4th times b to the 2nd gives me b to the 6th. Same thing here. Multiply all my numbers together. Let's see, negative 24. Yep. And then I can multiply my x's together, which would give me x to the negative 3rd. And then my y's together, which gives me y to the 10th. Just be a little careful here. The only thing that moves is going to be the x. Remember, it's just negative exponents that move, so negative numbers stay where they're at. So I get negative 24 y to the 10th over top of x to the 3rd. Just like that. When I have a power to a power inside of parentheses, remember that I'm multiplying. So this exponent on the outside is going to multiply by the exponent on the inside. So I get x to the negative 4th. And then in the second parenthesis, again, I'm going to go with the y, the x, and the 3. The exponent has to be shared between all coefficients and then also all variables. So I get x to the 4th, and then in the other one I get 3 to the 4th, x to the 4th, and then y to the 20th. Make sure we're multiplying there. Then I can have any like terms, so to speak. They're both x's, so when I multiply them, I add them together. I would get x to the 0 power, which gives me nothing. So I get 3 to the 4th and y to the 20th. If I wanted to actually simplify down 3 to the 4th power, that would be 81. So I could write it either as 3 to the 4th y to the 20th or 81 y to the 20th. Either way is a suitable example or answer. Here, again, share the 3 with both, so I get 3 to the 3rd, x to the 15th. Could either leave it like that, or if you want to do 3 to the 3rd power, that's 27, x to the 15th. With dividing, again, the way that I always do this, just to make it easier, oftentimes we're very bad at subtracting numbers for whatever reason. We'll forget to subtract a negative. So the first thing that I always do is I always move my variables first. So since that's negative, I'm going to move it down to the bottom. When that happens, there's nothing left on the top, so I have to leave a 1 on the top to hold the place of the top of the fraction. On the bottom, I then have b to the 3rd and b to the 4th. And so again, I can multiply those together to get b to the 7th. Multiply the b's together. The way that I do that is by adding the exponents together. Here, same thing, I'm going to move my y's first. My y's are just going to flip-flop places. So I get x to the 4th, y to the 5th, z to the 8th, over top of x to the 4th, y to the 1st, and z. Then I can go ahead and, again, I've got kind of like terms here, x's, y's, and z's. I can go ahead and divide them by subtracting them. So I get x to the 4th minus x to the 4th will give me x to the 0 power, which doesn't make a difference. Y to the 5th divided by y to the 1st, I can subtract my exponents to get y to the 4th. And then z to the 8th divided by z to the 1st gives me z to the 7th. Just remember that when I'm dividing, my answers always go on the top here. So when I'm subtracting my exponents, my answer always goes on the top. So that's why I got a regular x to the 4th. It's not like it went to the bottom or anything. It stays on the top. It stays a whole number. And then the last two, with problems like these, the 4th power on the outside has to go to the top and the bottom. So I can kind of, I can rewrite them as 3x squared to the 4th power, and then on the bottom, x to the 5th to the 4th power. And so again, that 4th power can be shared between the top and the bottom. 3 to the 4th, x to the 8th. Remember, power to another power means multiply. And then x to the 20th on the bottom. So again, these x's are my like terms, and so I can subtract them. When I do that, again, the 3 to the 4th is going to stay on the top. And when I subtract those, or I'm dividing them, so I subtract my exponents, I get x to the negative 12th power. And so again, when I do that, x to the negative 12th, it goes on the top first. And then since it's negative, I'm going to move it down into the bottom. So I go 3 to the 4th over top of x to the 12th. And I could write that either this way, that's a suitable answer, or I could write it as 81 over x to the 12th. Same thing with this second one. I'm going parentheses 2x to the 6th to the negative 3rd power over top of y to the 4th to the negative 3rd power. And so what I can do is, again, share this exponent between the top and the bottom. So I get 2 to the negative 3rd, x to the negative 18th, and then y to the negative 12th. Everything's negative, so everything's going to flip. I get y to the 12th on the top, and then on the bottom, I get 2 to the 3rd and x to the 18th. If I didn't want to write it that way, this is a totally good example, or answer, and I could write it as y to the 12th over 8, x to the 18th. Either of those answers are good. If you flip over to the back, with a radical sign, I know that my bottom number, if I ever have a fraction exponent, the bottom number is my root, which is going to go in the crack of the square root sign. The top number is my exponent. That's all that this is saying. So when I do a problem like this, just put an arrow up to the 5. That's my exponent. and then the 6 is going to be my root, which is going to be the number that goes in the crack of my square root sign. And so when I write this, I want to do my square root. Again, the 6, the denominator goes in the crack of the square root, and then inside the square root is going to be a to the 5th power. And I can just leave it like that. With this one, the one thing we need to be careful with is this 3/4 power just goes to b. Those two things go together, the 7 doesn't. So the 7 stays outside, and then the b is the only thing in the square root sign. Again, 3 is the exponent and 4 is the root, so I would leave my answer just like that. And then the last one, since there's parentheses, both of these things will go into the square root sign because the thing immediately in front of my fraction, or my exponent, is the parentheses. So everything goes in the square root sign. Again, 3 is my square root, and then in the parentheses, in the root, I have to keep the parentheses because the 2 has to go to both of those things. And that's my final answer. To flip it around and go the other way, again, I can do this. So just rewriting it, I could write it as b. My exponent is 3. My root is 5. So I could write it as a fraction exponent. With this one, I have just a regular 15. And then again, in my square root sign, it would be y to the 4/7. This is my exponent. This is my root. Exponent goes on top, root goes on the bottom. And then the last one, just be a little bit careful with, c to the 10th power, and the 10th power only goes to the c, so the actual exponent of this 32 is just a 1. And so when I write these out, they both are going to have different exponents. So I'm going to go 32 to the 1/5 power, and then I'm going to go c to the 10/5. Again, we could leave it that way, or we could go 32 to the 1/5 power, and then c to the 2nd, reduce that fraction. The last thing with exponents is exponential growth and exponential decay and compound interest. This is the formula that goes with these is by what we have here. It's not quite as hard as it seems. So a sculpture is increasing in value at a rate of 8% per year, and its value in 2000 was $1,200. And then write an exponential growth function to model the situation. The only things that we need here is we need to have, we're going to do A is going to be our starting amount. So the starting value of this sculpture is $1,200. Our rate, which is the rate that it's increasing at in this case, is going to be 8%, which is 0.08 as a decimal. And then the time that goes by, that's all we need. The time that goes by is going to be 6 years. And so what we want to do here is my exponential growth formula tells me that I can go y is equal to, it's always my starting amount. And then since it's growth, I'm going to do 1 plus my rate, and then the exponent is going to be the time that goes by. So it's going to be, in this case, y is equal to 1,200. And then in my parentheses, I'm doing 1 plus my rate, which is 1.08 to the 6th power. And so when I do this, I get 1,200 times 1.08 to the 6th, and I get 1,904, and then it rounds up to 25 cents. Just like that. So starting amount, rate, and time. Take the starting amount. Since it's growing, I'm going to do 1 plus my rate, and the time that goes by is 6 years. With the second one, population of a town is decreasing at a rate of 5% per year. In 2000, there's 1,700 people. Find the population in 2012. So again, A is going to be my starting amount, which in this case is 1,700 people. My rate, again, this is a rate that it's decreasing by, is 5%, which is 0.05. And the time that goes by is, in this case, 12 years. when I'm doing exponential decay, so this is decreasing. So I go y is equal to my starting amount, which is a, and then I multiply it by, it's going to be 1 minus my rate, and then time is my exponent. So I go y is equal to my starting amount, which is 1,700. In my parentheses, and just do this in your calculator, 1 minus 0.05. Sometimes we just make it a negative number and subtract it the wrong way, but it's got to be 1 minus 0.05, which gives me 0.95. And then the time is 12 years going by. So when I do that, I go 1,700 times 0.95 to the 12th power. I get 918.6, so 919 people left in this town. Then the last one's compound interest, which is about the same thing. So my starting amount is, in this case, $1,200. My rate is 2%, which again is 0.02. The only thing that's different is now I've got to take into consideration the number of times that it's compounded, which is the time that the interest is applied and then reinvested. So if it's being compounded quarterly, quarterly means 4 times in a year, and then the time that goes by is going to be 3 years. And so again, when I write my equation here, I go y is equal to a, parentheses 1 plus my rate divided the number of times it's compounded, and then n times t is my exponent. So when I do this, I get y is equal to 1,200, parentheses 1 plus 0.02 divided by 4. And then in the exponent, I go 4 times 3. Just make sure you do the exponent first when you plug it into the calculator. So I get 1,200, 1 plus 0.02 divided by 4 to the 12th power. And so when I do that, I get $1,274.01.